Hey guys, it's Vince. Today I'm in the shop and I am done now with the SMCU unit. She is totally wired, and the only thing I have left to do is actually attach the ribbon cable from the UC400, which again will be made custom to length. And of course, we are going to do the graphics for servicing of the unit for whichever client decides to purchase the unit. So let's take a look at what it looks like completed, because this is a very, very unique system. So coming in, you can see we have our ferrites placed on all of our motor connections, minus the shield drain. And I've stated this in the previous video, you only need to filter or use double shielded cable on leads carrying signals. So once again, the signals are the ones that are being protected by ferrites. Underneath these, you'll notice the TDK ferrites, and that's for our inputs for our switches. Everything there is connected and on this terminal splitter right here, and it comes right into the SMC unit right here. So you can see now just how small these leads actually are. I mean, these are tiny, probably no more than 6 to 7 inches in length. When we look at this, you can also see our ground bus allocated for all of our shield drains. Now, I've already done a power test on the system. I'm going to do another video showing you it totally complete. We'll run it up with some motors, see what kind of RPM we can achieve, which should be very, very impressive. But overall, it gives you a basic foundation for seeing a system that's done with every base covered as it should be. Now, looking at the ground bus here, you can see the amount of leads that actually have to be connected for all of our shield drains. These are just for the double shielded cables that'll be plugging in to all of our aviation connectors here, these GX16s. And once again, we have a 5-pin on top for our motors, and we have 3-pin on the bottom for our switches. Now, again, this can be configured differently based on what a client will be using. If a client is going to be using proximity switches, or different types of switches that may require an additional lead, they can be swapped out with 4 or 5-pin if required. However, under general pretenses, most end users will use the standard snap switches, which work just as effectively. And again, you only need a 3-pin GX16. So you can see here how this is all set. Keep in mind, and I've stated this before, when you guys are assembling your system, you will always need an additional pin on your aviation connector to support your shield drain. That's in best practice, so that you'll be utilizing double shielded cables. Again, we've got 4 leads here for step and direction signals for our motors, and the 5th pin is allocated to the shield drain, which now goes to the ground bus. And you can see how everything is set, and it's no different once again for the switches. 2 pins of these GX16s will go to the drive itself, one going into an input on the drive, and that's this connector right here. You can see all the blue leads. Those blue leads are all the switches. And then on the bottom over here, we have a terminal split for the VSW signal, which is a positive signal, and that's coming in right here, and we split this single lead, once again on the drive, right here. We split that down, and it comes down to this terminal splitter and splits it out, so we prevent daisy chaining. And that's exactly what we've done here. So you can see exactly how neat an integrated 4-axis drive system that supports up to 9 amps can look. This is insane, because considering the fact that this enclosure is 16 inches by 16 inches in width, this is a lot of electronics in such a small confined space. And you can see we do have proper cooling with 1 fan for intake, 1 fan for exhaust. And again, this is truly amazing in the fact that you're able to do this with drive integration with that motherboard present for all of your drives, and including your power supply breakout module. This makes everything much, much neater. And you can see that right here. There is no breakout board. You don't see a breakout board present. You do see the step down. This is a secondary power supply, which provides 24 volts. Once again, for logic, which is the breakout board or motherboard built into the system. And then it also comes over here to our UC400 and provides it voltage as well. Now, I don't know if you can see it, but right here is the voltage that you can actually use with a UC400, which goes up to 24 volts. It'll take 12 volt in and go up to 24 volts. So looking at this, you guys can see exactly what we've done. Now the E-stop, this is interesting. I actually went over here, just used some single wall heat shrink, went over with a TDK ferrite there, went over with another TDK ferrite there, and you can see if you heat the heat shrink properly, you can actually mold that wherever you'd like to go. I did that same thing with the fan right here. This way you can see the lead coming in. Everything is done nice and neat. It comes over and it goes right around the system, and once again comes up here to the front of the power supply where everything plugs in. Secondary fan right here, you got the same principle. So everything is neat, but with a drive that's integrated with the individual drives themselves, meaning that the drivers go into the motherboard, it mitigates at least 60% of the wiring. So you can see that right now. I've also utilized the drilled holes that are in the drive's actual heat sinks for the silicone leads to come in and actually power the system. This keeps everything very nice, and you don't need to use an excessive amount of wire ties. So again, whenever you guys can use the holes that are already provided for the system, study them carefully, and you can go through, wire everything in a very, very simplistic format. Now, what I want you guys to do, and I tell you guys do your homework all the time, if you go online and you look for a 4-axis system that supports up to 9 amps, I want you to find one in this size constraint. It'll never happen, because drives that would support that on top of an IDS or individual drive system, you would have a breakout board. You would need a much larger chassis, typically over 20 inches, just to support the amount of electronics in there. So looking at this again, thinking about the shipping on this, especially for my international clients, because I get asked about that a lot, this system can easily be shipped internationally. You see the numbers on the front. I get asked about that a lot. I number all of the switches as they're actually connected to the drive. Now, why do I do that? Naturally, when I'm going to label everything, it makes it much easier to know which is which, and then I can label everything for my clients. Okay, so this is about, right now, I'd say about 95% done. Once the graphics and servicing diagrams are done, everything will be done. But you can definitely see just how simple this is in terms of the wiring. Okay, once again, using all the holes in the drive that were provided, anything I could do to mitigate actually having to use wire ties for all the hookups, it streamlines the entire process. And I cannot emphasize that enough. As a matter of fact, if you look at our live, neutral, and ground leads, they're coming, just as I've identified in previous videos, right underneath our step down. Step down is elevated, once again, to provide space, so naturally it doesn't short out on the chassis, which is conductive. But on top of that, being elevated allows me to run the leads nice and neat right underneath into our power supply. Okay, so you look at this, and I cannot emphasize enough, for my guys out there that want to build their own system, this will take your ideas to the next level. I mean, if you look at how simple this is in conjunction to what's online with something of this caliber, on top of the fact that it actually has a braking circuit built in here to dissipate any back EMF, there's nothing like it, guys. Nothing. And it goes up, once again, to 256 microsteps, or 51,200 steps per revolution, which is just ridiculous. You will never, ever really require that. Most systems I've never seen require that. So looking at this, looking at, again, what it looks like finished compared to what we've seen, there's just no comparison. And again, this doesn't have graphics on it yet. It's going to get even easier for whoever purchases it, because they'll have the servicing graphics they need. Once again, looking at it from this angle, you can definitely see here, this is our voltage breakout, and this is for our step down. Naturally, the step down only has one voltage out, and a lot of step downs are like that, which are nothing more than just a step down power supply. But being it only has one terminal here, a lot of guys will say, well, I'll just daisy chain off of this one terminal. We've seen that done. You don't see that being done. What you see is the leads coming over, and then each side of this terminal block represents hot and represents the negative on that power supply. And then you just hook up your accessories. So UC400 uses 24 volt, it gets hooked up. The logic on the board, meaning the motherboard of the drive itself, it gets hooked up. That is what not doing daisy chaining is. You're essentially wiring each individual component as its own separate entity. You're not just linking one right after another. I get asked about that a lot. You can also see the leads coming in behind the board. I came in here all the way underneath to keep everything super neat. Once again, that's the beauty of using silicone leads. You can do that. You can see how everything comes right in. Boom, boom. Nothing to it. Very, very simple. And looking at how short these leads are, don't get me wrong, wiring any system, if you've never done it, you're going to have a lot of leads. And you'll notice everything has to be cut on the first system custom because you don't have templates made or should have templates made. If you're building systems, you make templates so you know what lead length you'll be doing on the next system. If you're doing it for the first time, of course, it takes you the longest because you have to go through, measure each lead accordingly, and cut them as each one is being completed. So when I see guys crimping and they're doing things super, super quick, and you think that every lead on this system is soldered as well as being deoxed, every lead has deoxit, which NASA uses. If you don't know what deoxit is, look up KEG. Deoxit gold is on every single lead, okay? This stuff is amazing. The bottle is tiny. It is not cheap, but I do that on all my systems. Once again, it just adds peace of mind. And on top of that, everything is protected. But I hope that this gives you guys a visual perspective of just how easy future systems can be. Because the 540 I love. It's a great system. It does have some limitations. The main limitation that we've seen is it can only handle motors up to 3.5 amps. And that's something that is just inherent of the drive. That is the ultimate beauty of this. Basically, what we have here is an individual drive system with the capacity of going up to 51,200 steps per revolution, or 256 microsteps, on top of the fact that it's integrated. So now we've got all of that, and we've got relays, and we've got our spindle control and everything added to this. And it's going to get even better. This is the starting model. We are going to have it with the GX16s mounted directly to the drive, like a G540 with its DB9s. It'll have GX16s that'll allow motor cables to plug right in, eliminating even this wiring. And then it will have a ground bus built into the drive. So once it's mounted into your electrical enclosure, it'll ground out itself. So therefore, you can see we can streamline this entire process even more. But for those that want to hit the ground running, this is the fastest system to build, bar none. And I've been working on this. I've probably got, I'm guessing, about 2 weeks of maybe 1 to 2 hours at a time. And of course, I'm ordering things, I'm doing things, I'm engineering it. But if you're doing it yourself, the real question here is how much time you want to allocate. And I hope you watch some of my videos where I discuss, take your time, plan it out what you're doing. Again, I do this as a profession. You'll be doing it for yourself. Time should just be an abundance of what you're doing just to get this system set up correctly so that you know every base is covered. But if you do it this way, utilizing ferrites and utilizing them on all of the connections that are this short, you do not need to mess with double shielded cable within the electrical enclosure. And the only reason YouTubers or content creators don't do it is because they don't understand it, because there's no money investment here per se. It's more knowledge of the frequencies you're working with, and then also dealing with the fact that they understand EMI, which many of them don't. But looking at this, you can see just how easy this is to do. I mean, it's not hard at all once you guys have a good baseline understanding. And once again, we eliminate the majority of the wiring, which again is the breakout board. I mean, considering this, on these drives alone, just with the motor lead connections and the shield drain, and then on top of that, step and direction settings, you're probably looking between that and the breakout board hookup of between 8 to 12 leads on every board. And that would be multiplied by each individual axis. So let me be very clear on that for my novice guys. That means if you were wiring this as an individual drive system, for one drive, every single drive, you would have between 8 to 12 leads minimum. Now multiply that by how many drives you have in your system or motors. Motors equal axis because each motor is controlled by its own driver. So thinking about that and thinking about that additional amount of work, and that doesn't include the machining to mount the breakout board. It doesn't include then going in and factoring in, okay, if I want to put a brake in for the system for back EMF, I would have to mount that as well. Oh, and if I want to mount relays, I'm going to have to mount that as well. I'm telling you right now, this is insane. Right there's the relay 1, relay 2. Not every system will use 2 relays. It depends on how it's configured. Right now, I do have the system wired up for VFD operation to cycle it on and off. That's all set. And factoring in that now, this is a system that will be considered max for most end users in the sense that it has all switches for each axis. E-stop, of course, on top of all motors wired, on top of VFD as well. So this is the ultimate, so to speak, for most end users, minus the fact of ATC support, which of course it would have, pending, of course, your motion control software could support that as well. So again, take that all into consideration. If you're serious about getting involved in production robotics and you want to get involved in CNC and you have very limited knowledge, research this. Research what you're seeing here because it doesn't exist. I've looked very, very hard. I've worked very hard to find that. I wanted to bring that to market because I realize that a lot of guys that are doing this, the more wiring we have, the more variables we have when it comes to problems. And that's where problems usually show up, is that there's just so much wiring to do. It's just, hey, I want to get done. Rather than, hey, I can just snap on ferrites and I'm good. Or, hey, I could just hook up my switches and they just plug right into the drive. Everything is set. So keep that all in mind. And even like I said, and I've said this in previous videos, just with these leads alone, just on top, plus the VFD, we're looking at 25. And then we're also looking at, on the bottom, an additional 15. So if you had to solder these GX16s, right there, you're looking at 40 leads right there. I believe I'm correct. Yeah. My accountant, of course, is shaking her head, so I know I'm good. But overall, this is where you guys are at. And I hope that these videos are helpful. It really will make many of you understand what you're getting involved with. Just look at the systems that are out, regardless of if it's a fail video or not, you're still going to see a guy wiring an individual drive because, of course, like I stated, they can get them really dirt cheap from China. And, you know, they're going to go through the whole gamut of wiring that individual drive. Unfortunately, many of them don't realize the reason it's so cheap. Number one, it doesn't come with support. Number two, it requires everything to be done to it. So just because this system's integrated, and I did all this, if you buy a system that's cheaper, and this is what a lot of guys think, they'll buy, you know, a stepper on live drive or another brand, you still have to wire it this way. There is no way of getting around that, guys. The only difference is that this one is done in a format, once again, using a motherboard. That's basically it, where the drive's plugged directly in. Similar to a PC motherboard, where the hardware actually plugs into it, the hardware components, your video card, all of your CPU, whatnot. It's the same principle. So hopefully you guys have gotten a lot out of these videos. Once again, I will shoot the final video of it assembled with graphics and, of course, hooked up to a motor so we can see what kind of RPM we can put out. The specs have been very, very impressive of what has been on Pitar's channel. And I will put a link so you guys can see at what voltage he's running. Now, something I did not cover in previous videos is This unit is stable up to 200 kilohertz. So for my guys out there using stepper motors to go faster for applications, not so much torque related, but just faster. If we're doing rapid motion, if we're looking at very, very light loads, because again, steppers lose torque the faster they go, this system will allow for a much higher rotational RPM because we can step our frequencies up. That's tremendous. Okay, of course, the UC400 will support that with ease. And again, in an Ethernet format, you guys have bulletproof signals. So we will now have control of the system using double shielded Ethernet cable, which again comes with the system. But this will take everything to an entirely different level as far as control that's currently available. That means for the guys out there who always ask the question, can I use any Windows operating system? Yes. You will be able to use Windows 7 through 10 in 32-bit architecture or 64-bit architecture. You can use Mach 3, UC CNC, Mach 4. Even though I'm not a fan of it, you can certainly use it. So again, lots of options, but speed, without a doubt, should be very, very impressive, and that's what I'm really looking at doing. I'm going to post a video from Pitar's channel of him testing a Nema 34 motor, which is very, very impressive in the RPM he was able to achieve at a very low voltage. I believe it was like in the neighborhood of 30 volts. So very impressive. And just to give you an idea, once again, we are running 50. We can go above that on my 48 volt power supplies. A lot of guys don't know that, but this power supply has got some horsepower itself. It can be turned up. I really don't want to push the barrier too much. We don't need to go too crazy. But overall, it does have the power to do it. And of course, it's got the built-in EMI filter. And you can see how nice it is now having the V plus and V negative terminal block where everything splits out. Because if you look here at these leads, guys, you got 1, 2, 3, 4, and then we've got 1, 2, 3, 4 leads on the bottom. Technically, most power supplies be already pretty much tapped out as far as what connections we can connect after that. You've still got plenty here. You know, you're looking at 6 leads on top, 6 leads on bottom for whatever accessories you need, if required. So either way, I hope that, again, these videos have been helpful. Please pardon the phone. Of course, that always happens when I'm recording. But either way, keep the questions coming. If you guys have any questions, let me know. I'll do my best to answer them, and I will follow up once again with the latest video of me covering the system and actually going through and testing some motors, because once again, I do need to get some resistors for the motors. And again, this is all part of it. And once again, also getting the ribbon cable, because again, you can see the short distance we have here. So again, I thank you all for your support. Take care.